right? This might take some time. You have to think and do it. So I'll give this as a homework. Just give a try how to draw the shape and keep it in the memory without doing it in the same time. So otherwise you are drawing like one by one. I just want to draw and keep it in the memory, and later when you request, suddenly display in the screen. Right? Drawing stage I don't need. Right? You can just Google it like small research. Drawing stage I don't need. So I just want to draw and keep it. So then after drawing, no need to show. When I ask the variable value, then it can. So when I ask triangle, then it should give a triangle. When I ask, but not drawing that time, right? So it should be pre-drawn and kept in the. Okay, do this as a small research, right? The question is basically, I asked you to draw. So did you see how Gayatri has done that in the beginning of the lesson? So actually, I have also done the same. Draw in a shape, draw in any shape, right? So basically, but that is happening as a process. No, process means when you call this, it starts drawing. ඔයාලා call process එක ඔයාලා call කරාම function එක draw වෙන්න පටන් ගන්නවා. මට එහෙම නෙවෙයි ඕන. මේකම draw වෙලා තියෙන්න ඕන. All shapes should be pre-recorded, pre-drawn and should be stored. Right? Later, when you call the function like this, shape should be there. So this is a triangle. So when you call the function, triangle should be there. This is a rectangle, or this is square should be there. Pentagon should be there. Hexagon should be there. So when I ask hexagon, then so you should be the screen should be populated with the hexagon. When I again ask hexagon, another hexagon. Likewise, a drawn one should be displayed. So that is the requirement. Okay, so please try this using functions. Okay, next is recursive functions. Next is recursive function. Something is recursive if it is calling itself inside the particular function. So see here. So there's a function, this function called loop, and that loop is called inside the same loop. So the main function එක ඇතුලේ ඒ function එක ආයෙත් තියෙනවා. The loop is called inside the loop. So that is called recursive function. So let me show something. Okay, I have a function like this. Let's say, so my function is I'm going to take a new one. Let me save as a file. Save as. I'm going to save this as recursive functions. Py. And what I'm going to do, I have a function that say hello. And that is basically printing. So this is a process, but anyway, you can call it as a function also. So printing hello. And after printing hello, what it does? It calls the same function. Say hello again. So what will happen if I run this function? Can you tell what will happen if I run this function? Say hello is printing hello. After that again saying hello. That say hello is printing hello. After that again calling say hello. What will happen? Yes. Say hello is printing hello. After that again calling say hello. That say hello is also printing hello. That say hello is also calling say hello. That say hello is also printing say hello. So what will happen? Sorry?
Repeat it.
Yeah, it will repeat. It will repeat how many times? How many times? Yes. Say hello. How many times? Is there a limit? Or limitless?
Limitless.
Limitless. You can see it's hello, 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 hello. Until your memory is filled, it's calling say hello. So until your memory is filled, it does. So it's limitless. But so in recursion, so you can do something, you can limit it. Maybe you can say, okay, let's have a counter. Let's have a counter like, okay, this. Let's say, okay, let's have a counter here. See. Right, initially I'm telling, okay, C. So then, so I'm telling if C less than 10, if C less than 10, then only you have to print print hello and say hello. If it is less than 10, then the second time you are calling C plus 1. Say hello C plus 1. C less than 10. So let's say C is 1. 1 less than 10. Print in. Now 2. 2 less than print. Print in. Now it's 3. 3 less than print. So now what will happen? So less than, let's say less than or equal to 10. Now what will happen if I run this? Say hello. And I'm telling 1. So it's printing 10 times. After that, it is over. Because if it is less than, so here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Because it has a terminate. If it is less than 10 only, this, otherwise what will happen? This will continuously happen. You will not be able to stop that. You can forcefully stop. That is a separate case, but not naturally. Right? It will fill your memory also. Okay, so now I just need you to use recursive functions. So please use recursive functions and try to print these patterns. Try to print these patterns. So first of all, just print these patterns, right? So using the, so please write the recursive function as the heading. And then write this note. Then show this. Then you can show this example that I have right here. Just show that example. Sorry. Too many windows. Right, just write the recursive function and then write the note. Recursive function, then write the note. Then do this. Then do this example and try to print following 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Try to print 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. Then try to print square numbers from 1 to 100. Then try to print these two patterns using recursion. Okay, many examples. Let's do one by one, right? Let's do one by one. First one, so I have done one for you. So you have to try this one, so first one and second one. Then I'll help in doing other things. First, you have to try first one and second. Please write the note and try first one and second. You can see. This is the concept of recursion. Recursion means recalling the same function. No loops. You are not using any loops. Here to print hello 10 times, you are not using any loops. Instead of that, what you do? Call the same function. So you start from 1 and call the same function again and again until if it is less than or equal to 10. So this is very easy. if you have done something like this, if you printed C here, so then what will happen? It will print numbers, right? Basically, if I say hello 1, so it's printing numbers from 1 to 10. And if you want that to be horizontally, you can say end with space. And then that will be horizontal print. Then the say hello 1 will be printing horizontal number pattern. And if you need 2 by 2, just go 2 by 2 up to 20. Right? Start from 2 and go 2 by 2 up to 20. Or start from 0 and go 2 by 2. So let's start from 2, 0, 2, and printing up to 20. If you need odd numbers, you can start from 1, 0, 1, and now it's printing odd numbers. Understood? You have to change only one place. And for the second one, of course, you have to change 2 places, but the first one you are changing only one place. If it is 10, and it's going like 1 by 1, it's printing 1 to 10. That's all. Right? And you can, maybe you can create the same function to print. So let's say type. And so let's say category and limit. You can further increase the, further change the function. Right? Category and limit. Limit I'm going to give it here. Limit I'm going to give it here. And category. Category can be like, okay, let's say if category is equals, this is additional thing, right? So yeah, I don't think that will make this complex. Just go move in this way. So it has only C, right? Only one variable starting from C is going up to 10, the first one. So please write this for first one. Easy one, right? I have just given easy, very easy one. So then how to print numbers up to recursion, but you don't use loops. Loop, if you are using loops, that is same previous repetition. Repetition uses loop, but recursion, it doesn't use loops. Instead of that, it uses the same function. So let's say up to 20, you want to print 2 by 2. And this is say hello 2. Okay, let's run and see the outputs of each. Say hello is this one. And say hello, if you tell say hello 2 and you start from 2, you can say it's printing up to 2. You have to go 2 by 2. Say hello 2 is starting from 2 going 2 by 2. So what has happened? See, say hello 2, 2, 4. After that, what's the change? So let's enter 1 to that. You are calling say hello. You have to call say hello 2. Sorry, it's my mistake. That's why it's printing like that. Okay, let's run this say hello 1 and printing this one, say hello 2 starting from 2, it's printing even number, say hello 2 starting from 1. If you give that, it will print the odd numbers. Okay, you can print all 3 patterns. Understood? Understood or not?
Yes.
In recursion, don't use that repetition, right? Don't confuse. Repetition wala thamma loops pavichi. Recursion wala function name ekuma thamma I call. Okay, square numbers. Square numbers can be done same way. Right? This one can be used to print the square numbers. Let's say square SQUARE, and you are printing C into C. Incrementing C by C 1 by 1. C equal C plus 1. sorry, you have to tell the square, SQUARE, square C plus 1. And then if you run the square number pattern, you will get here SQUARE, square number starting from 1 and sprinting up to 100. Easy as that. That is for the square numbers. Kalitum, what you have given? Okay. Then, so you had like function like this. So there was an example like this. You can see this is Fibonacci series. We already discussed how this is calculated just by adding this number both together. And then 1 and 2 is 3, 2 and 3 is 5, 5 and 3 is 8, 8 and 5 is first two numbers added and generated the second number. So how to do that? Let's say def, I'm going to write a function called Fibonacci, and I'm going to give any n, Fibonacci n. So basically, if this n is equal to 1 or n is equal to 2, n is equal to 2, you know, you have to return. So let's use return function. If this is 1 or 2, Fibonacci 1 and 2, you know, it's the value of Fibonacci 1 and 2 is 1. Fibonacci 1 is also 1. Fibonacci 2 is also 1. Fibonacci කියලා කියන්නේ මේ series එකේ නම. දෙකක් එකතු වෙලා තමයි ඉස්සරහා එක හැදෙන්නේ. 1 plus 1 is 2. 1 plus 3 is 2 is 2 plus 1 is 3. 2 plus 3 is 5. The ඉස්සරහා numbers දෙක එකතු වෙලා තමයි මේක හැදෙන්නේ. Just add in the previous two numbers. Okay. These two numbers will be added and placed. Then these two numbers will be added and taken this one. These two numbers will be added and taken this one. These two numbers will be added and taken this one. So how to do this? First two numbers you know. Fibonacci 1, 2, you know. Fibonacci means the series name. 1 and 2 is 1. Return 1. Else, you have to tell else what to do. Return. It is Fibonacci, the previous Fibonacci, Fibonacci n minus 1 plus Fibonacci, you can say n minus 2. N minus 1 plus n minus 2. Okay, now let's see. Let's apply the Fibonacci. Let's try Fibonacci 3. I need the Fibonacci 3. Need to print the Fibonacci 3. So let's run this and see Fibonacci 3. Invalid syntax. It's O. Let's run this. Okay, Fibonacci 3 is 2. Fibonacci 4 is 3. Correct. Fibonacci 5 is 5. Now you are getting these values. Now you need all the Fibonaccis. To get all the Fibonaccis, you can just apply this kind of recursion. Right, this kind of recursion. Let's say def print fib. Print fib is taking Z as the counter. If C less than or equal to 10, you do print it. What we are going to print? Print the Fibonacci C and end with space